Well, hi, good morning, and thanks for joining me here in my shop. I'm going to start replacing these wax paper capacitors in here. This one's already been replaced. Its replacement is sitting right here. But none others have been replaced yet. And one of them is just hanging free here, as I pointed out before, which goes I don't know where yet. So I think the way I want to approach this is I'm going to start with the capacitors that might be influencing the audio side of this radio. The audio output tube is sitting here. Yeah. And it's fed from the detector tube, which is sitting here. So looks to me like probably I'm talking about these two, maybe this one, and maybe we'll discover where this one is supposed to be, which would be interesting. So maybe what I'll do first is I'll look at the schematic and I'll try to identify these guys. That'll probably help me identify this one. This one could be connected to, well, this side is connected to the chassis. This one could be connected to rectifier tube, detector tube. Who knows? Maybe it was even around here at one time. I have no idea where this is really supposed to go. Looks like naturally it would fit here. But there's no such capacitor connection there, so maybe we'll sort this guy out. So maybe the next thing to do is have a look at the schematic, look at the audio circuits, spot some of these capacitors, and pick off a few for replacement. Let's take a look at the schematic here. Okay, we'll go down to the audio end here. So, well, clearly here's one. Can identify this one fairly easily. It's coming right off of pin 5 on the output tube. That's a very 25. No, that's probably certainly that's part of the 3-part metal can capacitor. This one is probably in that area. It's probably one of the ones I pointed at. That's 2. There was something going on with tone control. That's probably this one. 3. There's this one that's conveying, that's allowing audio blocking DC, allowing audio to the grid. These are probably all capacitors that we saw. Now, just moving ahead of the audio section for a second, right at the very end of the radio, here's the last IF. Goes through the detector. Now there's some audio that can be recovered in here. The part I just want to point out is this. This pi filter with these smallish capacitors is located inside this can, and I can tell because of the numbering. You see they got the pin numbers 1, 3, 5, 4, and 6. And this is inside the can out of view, including this resistor. I think this resistor is in the can too. So, just a little aside. Okay, so there's a bunch of capacitors in here. More than enough to cover what I've seen. Why don't we start with, let's see if we can find this one right here. So this is the blocking capacitor, prevents DC, plate level DC, so like 100 volts or something here, from getting onto the grid. It's a very, very important capacitor. Pin 5 output tube. Pin 5 of the output tube. Let's see. See what we can find here. A little pointer. Output tube. There's the pin. 8, 7, 6, 5. There's the capacitor. Where's it going? Very, very carefully. Let's just go into this pin of the detector tube. This pin is 6. Pin 6. Does it go to pin 6? Pin 6. Let's go take a look. Does it go to pin 6? Right here. Pin 6. So that's the first one, is the blocker. You know what I'm going to do before I change it? I'm going to test the radio and see what kind of... no, I did do this already. Didn't I do these voltages already? And found this was okay. You know, I'm very interested in this. Why don't we fire up the radio, measure this this voltage. Yeah, we can do that. Change the capacitor, measure it again. And we'll test the capacitor. This is such an important capacitor. A tiny amount of leakage would make a big deal in this radio. Okay, fire it up, measure the voltage, change the capacitor, measure the voltage. Everything is safe and ready to go. And we should see a negative voltage there. No antenna. Radio's working. DC. 150 volt scale. We'll put it on the 15 volt scale. I'm watching this meter. Can't see it for all the light. Hey, let's work in the dark. Voltage on the correct. Should hear this. Yep. Meter's going backwards. I've got this meter set on negative. Let's set it on positive. 15 volt scale. Way positive. Oh my gosh, that can't be right. That's suggesting there's 25 volts on there. Oh my gosh, have I got something wrong here? I must have something wrong. 25 volts positive on there? So I must have done something wrong here. So that's pin 8, 7, 6, 5. It's pin 5 of the output tube, and the output tube, what is the output tube? What was the output tube? Was it a 6F6? What was it? 6F6. 6F6. Let's see what the book says about it. 6F6. That's a big glass tube in this radio. I think that might be the original. It's not going to last long if it's really true what's on there. Peak audio grid number 1 voltage, 16 volts with fixed bias at 250 plate volts. So they could set this thing up for running with a 16 volt signal. Now what's the actual bias? Grid number 1, control grid voltage, fixed bias minus 24. Oh, you know what? I know what's going on. I know what's going on. Okay, so I'm reading the grid to chassis, but this has got a cathode resistor in it. Doi. So in fact, even though my meter is reading backwards, it is actually showing me what is effectively a negative grid voltage compared to the cathode. So in that case, now I can be all happy. 15 volt scale. It's only the 15 volt scale, so it wasn't even the 50. 15 volt scale, but 7 volts. About minus 7 volts. Now I've got the dim bulbs on, and what are we running at? 100 volts, so that would become a little more negative. But let me just take a quick peek upon the schematic and see if it doesn't give us a voltage somewhere here. It does not, of course. 400 ohm cathode resistor, we can check that too. Okay, so this capacitor does not appear to be leaking onto the grid, or the grid voltage control is quite strong. Well, it is strong, I guess. You know, never mind what I just said. I'm babbling now. Okay, power up before I make a bigger mistake. We'll take that capacitor out and we're going to test it. Kind of working in the dark here as far as I'm concerned. That might be generally true, regardless of how much light I have in here. Cutting wires in the dark. Does it look dark on the camera? It doesn't look dark at all on the camera. Okay, I got something in my cutters. There we are. Okay. Let's take a little bit of a closer look at this guy. So, lots of wax. The end is covered pretty good here. Well, typical. Doesn't look terrible. Does not look terrible. Let's see. Let's see. I'm going to put this on my capacitor checker here. Uh-oh. Oh, I hear cats. I hear two cats outside. Hello. That's my cat Peanut calling me. Okay, Peanut. Yes? Hello. You want to what? Now where's Shadow? Where's your playmate? You want to come in? Come on in. Come on. Hello. Come on in. Come on. See, he's, you know, while I'm saying come in, he's saying for me to go out. And so it's a little bit of a battle there between the two of us. So who's going to win that battle? Well, I'm the person. I win. Not really. And the cats always win in the end. But in the short term, I can get away with doing this here. Okay, so this test puts a small voltage, with this setting, puts a small voltage across the capacitor. If no current leaks through the capacitor, this will look like that. This eye will have this opening here. The more current leaks through the capacitor, the more this eye will be closed. In a really bad capacitor on this test, when I do the test, the eye will close, it won't even open. On a good capacitor, it'll close during the charge up process because there's current flowing, but as soon as the capacitor is full, it'll open up. Here we go. Half open. So this is not the kind of capacitor I think would work well in the position it was in. But it seemed to be doing the job, didn't it? -9 was the voltage there. Isn't that right? -9, -9, -7, -9, something like that. Okay, so I'm going to put in a new capacitor and we will test this guy again. Okay, let's give it a test here. See how we do. Everything's safe and good. Yep. Again, I'll be doing this with the dim bulbs in place. Just watching the voltage on the, watching it drop. Okay. Wow, last time we did this, the reading came up about straight up on here. Let's see if it's any different. It's a little different. 50 volts. The situation's gone from bad to far worse. What happened? Oh my gosh, there's... What am I doing here? That was 150 volts. Okay, so I got pretty quiet. What has happened? So this terminal on this tube is pin number, and there can be no doubt about it. .876. Pin 6 on the detector tube. Pin 6 on the detector tube. Oh, wait, I got a little bit of a bad image there, don't I? Pin 6 on the detector tube. Sorry about that. Just got a little. So, pin 6 on the detector tube. Am I doing the right thing? Pin 6 is the plate of the detector tube. What voltage does it have on it? Commonly, detector tube plates often don't run with a lot of voltage, but maybe this one does. And then that's separated, that comes over from pin 6 over to pin 5 through the capacitor I just changed. And there should be a 47 meg. What? 47 meg resistor? Maybe that's 4.7. The point didn't show up. Off that same pin. Pin number 5. Pin number 5 on the output tube. Okay, I'm trying to positively spot the key. It's really tough on that tube. Maybe that's where I made a mistake. No, I replaced the capacitor. From lead to lead. How could I have even gone wrong here? How could I have even gone wrong? Misidentified the capacitor. Come on, I want to be absolutely sure here. There's a good view of the key. 8, 7, 6, 5 on this tube. This tube is the output tube. I'm not crazy, am I? No, I'm not crazy. It's the output tube. Pin 5 on the output tube to pin 6. Okay, let's look at the schematic together here. So here's the grid on pin 5. It should have a yellow, purple, I'm not sure what color that would be then. It'd be green if it's 4.7. 47 megohms? I just leave it out. That's pin 5. Right to pin 6. There's a 0.27 here. This has got to be a 4 point. Maybe it's a point. You know what? There's a point right there. Aha, aha, aha. Okay, there's a point right there. So it's 0.47, so it's 470. I saw the 470 in the radio. 470, looking right now. There it is. Right there, right where it's supposed to be on pin 5. Yes, pin 5, and then it's supposed to go to ground. Yes, it does. So there's no question. I have definitely identified this. I've replaced this capacitor. I've identified this. Okay, this side comes over to pin 6. How can I get this wrong? You know what? You know what? Open circuit on this. Oh my God, that can't be the case. How can this radio operate? We'll look into this. We'll look into this. How do you get this monster voltage up there? Loss of ground here? I don't know. Can you even leak it from this side? What's the voltage on the other side of this capacitor? Am I crazy? Like a fox. Foxes never do well with electronics here. Okay, a couple things to check then. Okay, capacitor's in, radio's operating. Let's check some voltages here. I'm on the 50 volt scale, positive upswing. So grid, I think we should see nothing here. And cathode, the cathode right here, we should see something like 10, 15 volts. 15 volts. That's good. So we go pin 3 on the output tube. Resistor that way. Oh, I see it coming here. It's this guy. It's this capacitor that is basically across the output transformer primary. So I think this is to drain out any RF that's made it this far, but I'm really not sure of the purpose of this guy. 0.02. Let's check them out and get rid of them. So there should be a fairly large DC voltage across that, I think. Let's read both sides and see what we get. Could even be bigger than that. 500 volt scale on my glorious meter there. Okay, in the dark, what do you want to pick? Let's just check the B plus to get our reference here. 300 exactly. Now, here's the capacitor, here's one side. 300 exactly. And the other side goes here. 300. Well, you know, it's either if the capacitor is what I think it is, it's either side of the output transformer. I guess that would make a small difference across this capacitor. So we look really closely, difference in voltage, just under 300 on my meter. Whoa. Just at or just over 300, so a tiny voltage across here, which represents, I guess, the DC voltage drop through the output transformer. Okay, let's power it off. Go after this one. Oh, he's tucked in there. Wow, really tucked in there. Okay, well, I'm going to put the new guy in the same spot. Okay, I've cut him free. There he is. 600 volt, 0.02. Okay, let's see how this guy's working. $50 volts. So it opened right up. 150 volts on it. Not opening at all. This is quite typical of a lot of capacitors I take out. They seem to show kind of okay at 50 volts, but by 150 on this machine, the eye doesn't open. So anybody think that's a good capacitor? So I'll install the replacement, and well, we can't imagine it's going to make much difference to anything, but we'll do that. Okay, that's one done. Now, no reason to check the radio with that, I don't think. I'm going to go on to the next one. So we'll pick another. We'll get down to this guy here pretty soon. Let's do these ones. So it looks to me pretty clear. So this looks like audio comes out of the volume control slider through this capacitor, then reaches the audio shielded cable on its way to the amplifier tube, the detector, the amplifier side of the detector tube. And then this is the tone killer, the high frequency killer, this one. So this makes the tone control work. You just peel off a certain amount of the highs and dump them to ground through this potentiometer. So let's do these two guys. Let's just do it. I'll go ahead, change them both, then we'll test them after I get them changed here.
He went on to pick up 9 states in total, including Texas, which is the second biggest prize of Super Tuesday. Joe Biden is now clearly the front runner.
This campaign will send Donald Trump packing.
Bernie Sanders, who had been leading ahead of Super Tuesday, had a lukewarm showing last night. He didn't get as much support in places he'd hoped to do well, including Minnesota and Massachusetts, but he had a huge turnout in California, the biggest state of the night with the most delegates on the line.
But tonight, I tell you with absolute confidence, we're going to win.
This race is now shaping up to become a two-person contest. The establishment centrist candidate, Joe Biden, and the progressives.
No news in any of that. That's the Canadian national broadcaster, top story, American news. I think this kind of thing's happening all over the world, where your own local news, your own country's news are second to what's happening in the United States. What's left? Well, I only see this now. Let's go on the schematic, see if we can figure out what this is, because what's left? It has to be. So the situation has become so bizarre here. Pin 1, pin 2, pin 3. Pin 3 of the 6SQ7. Pin 3 has this capacitor on it. It's right there. See it? It's right there. Which goes to ground. Pin 3. Now we look at the schematic. And let me just zoom it up another notch here. 6SQ7. Go to pin 3. Pin 3. Like this, something is going terribly wrong here with what I'm doing. Pin. Okay, so 1 and 8 are joined and grounded. Are they brought around to 3? 3 is the cathode. Okay, I have the close-up camera ready to go here. Let's switch to that. Okay, here we go. There's the key. No question. There's the key. Right above it, the two pins, 1 and 8, joined together and connected to ground. Now, do they come around to 3? So I don't see any wire. And why would it? It's a ground terminal. So we go to 3. Okay, so I'm trying to center the screen. 1, 2, 3. If you look down, right at the socket base, you can see the number 3 written there. 3! Pin 3. We come up, goes to this capacitor. Pin 3 has a capacitor on it. The other end of this capacitor. Ooh, I think it's cracked right open there, right? Goes down, down, down to a chassis terminal. Off of pin 3. Okay, now I gotta stop looking at this and start looking at that. There's another wire. There's another. Wait a minute, there's something else coming off of pin 3. Pin 3 goes over to one of the transformers. So I'm looking up at the schematic here. Make sure I look at the right thing. Pin 3. No. I I'm practically in pieces over it. I'm going to pull the stupid tube out and see what tube it is that's in there. I just have the wrong... I just can't sort this out. Okay. And did it come out of the same socket? Yes, it did. Look, you can see right through now. 1. Okay, so pin 2 has this resistor on it. Pin 2, on the schematic, I see 3.3 meg, and that's what that is right there. Orange, orange, green. Oh. Hello?
Hey, Jim.
Yes, that's me.
Hey, Jim, it's Kyle Rosingwell calling. I was talking to you yesterday through email.
Oh, yeah?
Yeah, about the Auto C600 General Electric radio.
Sure. Okay, I'm all lost my mind here. Where were we? We were just proving out that this is the 6SQ7 without any doubt. And then we were looking again, at least I was about to, tracing these wires here. What's this one doing down here? Oh. So that is grounded. They didn't fish a wire around to this terminal, they've grounded it here, and that means the other side of this capacitor must not be a ground. I must be misreading it up here. Oh, it's a terminal. Oh, look at that. Oh, right. From one angle, it looks like it's on the chassis. And from another angle, you can see it's a terminal on one of the transformers. So, terminal on one of the transformers, terminal 1, it looks like this could be that corner capacitor that I thought might be the Wanderer. The Wanderer, still wandering. So if we assume now, let me get the longer shot going here. So pin 4, pin 1, oh my god. Why are they doing it like that? Why are they showing it like that? What's happening there? What's this? Is this a pin they failed to number? This is inside the can. But they've shown it. See, they don't have terminals shown here, but they showed them here. And over here, look at this. You have a 4 and a 6 and a 1, and that's going to be a 1, 5. They didn't number this. This is internal. Internal. This is sticking out, sticking out. So 1, 2, 3, 4, 5 sticking out. There's one more sticking out. There's 6 sticking out. There's 6 on each one of these. So that's what happened here. They didn't number this. They didn't number these. So when I see this is the capacitor that is tied. It would be pin 6. It's a corner. No, this is 6. Why did they put the number here, but they didn't put it over here? They put a dot here, but they didn't put a dot here. There's no wire running from there. This is 6. You got 1. Huh. Where's 2? I can't figure this out. Oh my god. Get the old meter out and start poking around that way. And this IF equals 460 is typed in here. Obviously, that's been added in. That's not original. Is it correct? You'd want to think so. Or should that be 455? Oh, man. Here's the radio that fellow phoned me about, which he was going to throw away in the garbage, but he knew of me somehow and decided you give it a chance. Giving it to me, so there you are. That's the General Electric C600. Okay, I think I figured it out here, where this capacitor is supposed to go, by identifying all the capacitors on the page, and then I was left with, see this or not, this transformer has a 0.02 here and has a 0.02 here. So at first I thought this guy up here that's still in the radio was him, but after very careful looking, no, it turns out to be this guy. This is the missing one. This is the missing one. And where can it connect? It can connect anywhere along this line, anywhere down, anywhere, anywhere, basically top of the 16. Top of the 16. So we look at the capacitor now and say, hey, Mr. Capacitor, where would you feel comfortable going? So one possibility is right up here, only I don't think this is at all what I'm after. Maybe it is, you know, there's a wire. Look at this. So this is the top of the 16 capacitor, this red wire. We could connect here, we can follow this wire up to this terminal. And look at that capacitor, it's very natural fitting there. And just before I started the video, I realized that when I'm standing here looking at the radio, I'm looking point on, right? I'm looking point on a cut piece of wire. You can't see it. Not until I get myself way over to the side, and then you can see there's actually a piece of wire sticking out here, which I was looking all over the place for, because I think that's the piece of wire that this came from. Don't tell me you don't reach. So connecting it here or connecting it over here, all the same stuff. I think maybe I'll go this way because it kind of likes it that way. That's it. I think mystery solved. Oh no, wait a minute. That's not mystery solved. That's mystery. That's a mystery big time. So it is this capacitor, who I believe its job is to deal with RF coming through here. Providing a ground for RF. That's missing. Then what was going on up here? I mentioned before I was doing a study with this radio, not quite realizing that maybe this capacitor missing is actually making the study actually more interesting. Okay, so I'm going to replace all these capacitors, and we'll be done with it. Nobody interrupt me now. Tuning the radio. So the primary and its harmonic stay still, but everybody else is on the move here. So it's the stuff that's on the move that is the mixing products. Ooh, one of those guys just popped up. Now there's another effect here too. The SDR itself, the thing we're looking at on the computer, it's got its own brain power. It's trying to do things based on what it does. What just happened to the local oscillator at round? What's happening there? What is that? The radio's tuned to 900. What's that great big thing there? Okay. That's I don't know. That's the bottom line of that. Keep going. Ooh, what happened there? Let's go back a bit. Oh my gosh. We come to some kind of wild zone right in here. Oh man alive. Somebody explain all that. The radio's now tuned around 700. Oh, what's that thing at 500? Oh boy, oh boy. Well, there you go. There's a look at what is coming out of a mixer as a radio is being tuned. I like that spot. Well, I think I've survived the torture here of trying to sort out what has happened in this radio, and I think I have an interesting story to tell involving this capacitor to nowhere. Who knows if my story is true? I think electronically it'll be true, but whether things got to be this way, the way I think they got to be this way, I don't know. So here it goes. This capacitor fits very nicely right here. There's another little tail. It's very hard to see, especially with my hand in the way here. Very hard to see. This is the tail I produced when I cut the capacitor that was here and replaced it. This other tail is virtually invisible. This capacitor was connected there. That's not the right place. It's not supposed to be there. It's supposed to be at the next spot over. There's no sign it was ever connected there. This spot I just pointed to is equal to this spot, right on this corner. Corner of this wire. This thing goes everywhere on the radio. Holy smokes. Trying to sort all that out just drove me batty because there are so many spare terminals in here. Look. That IF's got 6 terminals. That IF's got 6 terminals. They look exactly the same. Of the 6 terminals up here, 2 of them are spare. You know how long it took me to figure that out? Holy smokes. So, I pity anybody, next to doing strings, sorting out something that doesn't seem right in a radio like this is mind-blowing. So what happened? So this capacitor, when they built, this is my story now, they built this radio, the builder put this capacitor on the wrong terminal here. It's an easy mistake, just missed it by 1 terminal. Then it gets to the guys who test the radio at the end of the line and certify they're going to stamp it good and send it on its way. Turn the radio on, it's not working. Not working. So what's he do? It doesn't take him long to discover this capacitor is in the wrong spot. So we cut it away. Wait a minute, isn't he supposed to reconnect it? That's the problem with my story here. Alternate story. This is even stupider. Somebody discovered that if you cut this capacitor off this terminal, the radio works better. And that from the day it came out of the radio from the manufacturer, it has never ever worked properly until somebody discovered that and cut this capacitor. And then with the radio working better, they just left it. No, I don't know. I'm trying to understand how things get to be the way they are. Now what am I going to do about it? Well, the schematic clearly calls for a 0.02 on that circuit somewhere. It has to be installed somewhere. Installing it, this is a ground at this end. I can install it from this terminal where it's supposed to be to any other ground. I could use this one right here. It's right nearby. How do I know I got this right? A lot of time spent studying this. But I think what I'm going to do is I'm going to attach the ground side. I'm going to leave this floating. We'll cut this guy right out of here. And then with the radio operating, I'm going to connect it and disconnect it. And we'll see what it does. And I'm really quite sure if you put a capacitor to ground on this terminal that I'm suggesting it was on, the radio would be dead. It'd be grounding a main signal. I don't know. What a mystery. Okay, let me get that stuff done. Okay, so what I've done is I've installed the capacitor this end to the ground, but the other part is floating, and if I just push on it, connect. So let me do a little test there. Because this radio was operating without it, this guy, I'd get the old guy out of there. Okay, and put the tube back in for maximum performance. Okay. So I've done a lot of changes here without testing the radio too much in between. So what we're going to do is I'm going to reduce this to one light bulb in series. Volume's down. Okay. Power on with the dim bulbs. Hey, I thought this was off. Whoa. Okay, dim bulb acting proper. It's running on yeah, that's better. It's going down. Expecting that to come out around 90 or so with one bulb, maybe lower. Okay, 2 bulbs. We need a little more juice than that. No antenna, that's right. Well, radio's working. Let's put an antenna on it. Don't worry, I'll do it. Okay. Now I have the feeling the switch is thrown the wrong way for this, but that might be enough, just in the cable. My pointer's kind of giving up the ghost there. It's definitely on AM. Not very strong. So it's possible doing all those capacitors has in some way detuned the radio a bit, alignment wise. Where'd that one station go? Oh, I know. The antenna's not. The switch isn't thrown. Duh. Okay, I'm gonna run and throw the switch. Let me turn the volume down here.
G.I. Joe, and the neighbor reported him to the police because, of course, under bail conditions, he's not supposed to have any weapons. He was arrested, charged with that. He pled guilty a few weeks ago, and the victims.
Okay, that made a difference. Now we want to play with this capacitor. I think I can find a nicer station here. Get away from that noise. Can't get away from the noise. Okay, so I'm going to push that capacitor on there. Turn it down a bit. Maybe a pop. Spark. Not doing much for me. No wonder they cut it and just left it. It's You know, it's in the IF, so it really wouldn't matter if you're which band you're listening to or anything. Well, it seems harmless anyway, so I will install it the way it's called for on the schematic. And then it's verify the alignment and sensitivity and all those kinds of things. And we're done. It's that simple. Okay, turn it off, Jim, before you forget. Good. Solder that up. So that's it for now, anyway. So thanks a lot for watching. And next video, I think we'll just be doing the finishing up stuff here. I just thought of a new version of my story of how this happened with this capacitor. So this story goes this way. The manufacturer's fallen behind in the final testing part of his assembly line. And he's got 50 or 100 of these chassis already built, waiting to be checked. Finally, one of them rolls in to be checked, and the guy discovers this capacitor error. And he finds out that, what? Bill, did you do them all like this? Yeah, I've been doing them like that. Nobody came and told me otherwise. But did you look again at the instructions, would you? Oh my God, I've been doing it wrong. There's 20 of them like that. Don't worry, you know what? This capacitor is hardly necessary anyway. I'm just going to go into those 20 you built and just nip that capacitor out. We'll just leave it. Don't tell anybody. She'll be okay. That's my new story. Oh, I got another part to that story. So Bill's in a panic, but Ted says, hey Bill, you built them all wrong, but don't worry. We don't have to take them back out on the line and run them through again or anything like that. We'll just nip that capacitor on the 20 of them here in the warehouse. Don't worry, nobody will ever know. That's the new part. After this video, everybody knows. Bill, you've been found out. And whoever your supervisor is in big trouble now.